Dear students, this is a photochemistry topic. Another one important reaction, that is a Paterno Buchi reaction. It is learned nucleus. Once had the name, certainly you feel is a laughing, but it is very important reaction, Paterno Buchi reaction. Okay, that is nothing but is a photo addition of alkenes to carbonyl compound. Okay, it is a photo addition reaction. It's a kind of photo addition reaction of alkenes to carbonyl compound is an example of Paterno Buchi reaction. Okay, symbol of one alkene with one carbonyl compound, both are undergoing addition reaction. Okay, alkenes is always called as a olefins. Okay, alkene is otherwise called as a olefins. Okay, right. This reaction occurs normally between the triplet state of carbonyl compound and the ground state of olefin. Okay, that is very important. This is normally occurring triplet state of carbonyl compound and the ground state of olefin. So the important thing is triplet state of carbonyl compound in the triplet state and the olefin or alkene in the ground state. Triplet state, we know that it is a parallel spin. Okay, in ground state it is a paired spin. Okay, we go for the reaction. Okay, we are considering as a carbonyl compound. It is a benzophenone. Okay, olefin, we are taking some olefin. Okay, right. It's undergoing a reaction to form a two product. Okay, one is getting 90%, another one is a 10%. It is a oxetane type of product. Okay, both are the oxetane type of product. Is a ring compound will be formed. Okay, completely ring closing compound will be formed. Okay, right. So we go for the mechanism, then only we go we got somewhat understood. Okay, it is having one is a 90%, another one is a around is only 10%. Okay, another one is only for the 10%. So why it is getting like that is going for the mechanism will clearly understood. Okay, so first of all you want to know what is Paterno Buchi reaction. That is photo addition of alkenes to carbonyl compound. Okay, it is a Paterno Buchi reaction. So mechanism, this reaction complete in two steps. Okay, the first step, excited carbonyl compound in triplet state and throw its oxygen to the olefin and form two diradical. Okay, the first thing is the excited carbonyl compound in triplet state. Okay, and throw its oxygen. With oxygen it is bonded to olefin and also formed as a two diradical. Okay, so we go for that one. So it is a benzophenone. It is observing sunlight, that is H nu. It go for the first, it is go for the excited singlet state. Okay, that means it's a homolytic cleavage, just like that. Okay, this bond will be broken as a homolytic cleavage. Okay, one bond, one electron in the carbon, another electron in the oxygen. Okay, but the interesting thing is it is still in a single state. So it's a paired electron. One is upward, another one is a downward. It is a paired thing. So it is still in a single state. Okay, so we already discussed about that. So I'm not going across that one. Okay, right. Then next thing will be spin inversion will be take place. Okay, spin inversion. There's a spin will be changed. Okay, so it is the spin will be changed. It is a spin inversion. So it will go for the excited state. This is the excited state. It is coming the excited state. Okay, right. Then the excited state benzophenone with the olefin. Okay, you can simply put CH to CH2. Okay, it is an ethylene. So they are putting some substitution. Okay, instead of two hydrogen, they are putting two CH3. Okay, so anyway, it is an olefin. So already we mentioned it is bond through with the oxygen. Okay, oxygen bond with through with the oxygen. Okay, that means in the sense this it is indicate that okay, the single electron indicates that it is not is a radical. putting single electron or radical, both are having same meaning. Here we are mentioning triplet and single state, that's why we are putting the electron mark, otherwise we put a dot even, it is okay. Okay, right. So it is also a homolytic fission, this kind of homolytic fission to form a radical, both are undergoing forming. Okay, right. So we are getting like that. Okay, so this bond will be formed. Okay, this bond will be through the oxygen atom to bond the form. Okay, so very interesting thing is this is also having one electron in the upward region. Sorry, okay, I would just put it like that. So one electron in upward region, another electron is downward region. So upward and downward electron undergo bond formation. Okay, two upward electron do not bond any form. That's why it is called as a diradical. Already mentioning the electron is called as a single radical. Okay, you can put radical also. Okay, we can even is instead of the electron we can put radical. It's a single electron, so it is a radical. Okay, this is a first structure, it's a diradical. It is more stable. Okay, whereas the radical is present in a secondary position. Okay, that's in tertiary position, so it is a more stable. Okay, right. Go for the another charts. Okay, so alkene is react in this point of CH3 twice C double bond CH. The CH is directly joined with this oxygen. Otherwise, this group will be joined. That way, we are getting another chance. Okay, in another chance, the CCH3 twice group is present in the other side. Okay, that's the only thing will be different. So all other explanation will be same. Okay, anyway, here also homolytic fission will happen. One upward, another one is downward. Both are undergoing bond formation. So we are getting this one. Okay, so we are getting this one. Okay, so we are getting this one. Okay, in the previous one we are getting O bond CH2 here, O bond with CH3 twice. Okay, CH2 is here. Okay, so it is also both bond is upward. Okay, here also both bond is upward. Here is one is upward, another one is downward. That's why it is bond as a bond. Okay, right. So here it's a second radical. It is a second radical. It is a less stable one. Okay, less stable one, because previously we are in the more stable because the radical is present in the particular groups. Okay, here it is present in a CH2 group. It is a less stable one. Okay, so go for the second step. In the second step, spin inversion take place and the second bond is formed. It's very simple thing. Okay, in the second one, the spin inversion is take place in this area. Okay, spin inversion. So upward spin will be downward. That means this bond will be formed. Okay, just like that. And this is the first structure. Okay, this is the first structure. Second structure also the spin inversion will be occurring. It is formed as a bond formation. Okay, here is a bond formation. One of the spin will be reversed. That's a spin inversion. It is 10%. Okay, so already mentioned structure 1 is formed as a 90% because of the stable radical formed. Okay, stable radical is formed here, but the structure is only 10% it is formed as a less stable because of the radical formation. Okay, so that's about the Paterno Buchi reaction. Then we go for the one complication. Okay, we are expecting the cyclic product, so one complication will be there. So that's why we are going for that. Okay, so we are already studying carbonyl compound with olefins. The reaction proceeds through carbonyl compound with olefin. So we are taking in olefin point of view, we are considering as acetylene. Okay, that is CH triple bond CH. Okay, so they are telling acetylene also participate in the Paterno Buchi reaction to give product which probably arise via unstable oxytane. Okay, acetylene also involved in this reaction, but is formed as a probably it is formed as a unstable oxytane. Okay, it is giving a product, but is oxytane will be unstable. Okay, right. So we can saw the formation. It is nothing but it is a benzophenone. Either we can write PH2CO, otherwise we can write C instead of PH we can write C6H5 also. Okay, so it is benzophenone, don't confuse. Okay, it is acetylene. Okay, both are forming. So here they are not mentioning the electron. Okay, so instead of electron we are now providing a radical. Okay, so don't confuse. Okay, we are putting radical. Okay, here undergoing the changes. Okay, this is a homolytic division. So carbon having one radical and oxygen having another radical. So this carbon having one radical, this oxygen having another radical. Okay, this is also broken. Okay, this is also broken a single electron, so both carbon having single electron. Okay, so one bond will be broken, so double bond only will be present. Okay, so one of the bond in this carbon and oxygen both are undergoing form, that's why this bond is formed. Okay, so one bond will be formed, so another will be two electron will be there. Okay, so one from the carbon, another from that one hydrogen. Okay, so it's one CH, one from this carbon and one from this hydrogen because of the homolytic fission. Both this is also undergoing homolytic fission. The oxygen and this carbon will be already bond formations, remaining carbon and CH will be there. Okay, right. So next we go for the bond formation. We can write it either we can write spin inversion or total, maybe we cannot write here, so either we can write spin inversion. So after the spin inversion, what will happen? The bond will be formed. Okay, the bond will be formed. So it is an oxygen, but the oxygen is unstable. Because why it is unstable means it is containing a double bond inside it. Okay, so immediately the bond shift will be occurring. I already mentioned one bond is here, another bond is here, so it is formed as this is one. Okay, so this bond is here, we can get this product. Okay, but it is formed as a unstable oxygen. That is a very important. If you are using acetylene instead of olefin, that is double bond CH, double bond CH2 either, otherwise any substitution of the ethylene, you are getting a oxygen, stable oxygen, but it is unstable oxygen because of the double bond nature. Okay, that is a one complication of reaction. Students, I hope you are understood this reaction. Okay, study well. Okay, next class I will put on another reaction. Okay, thank you.